Okay. So one of the other things that we need to learn, another way of presenting our information, is the idea of cumulative frequency curve. When I was in high school, we call it maybe the OGIF or OGIF. The spelling is just this. The pronunciation may vary from who is pronouncing it. So this is the cumulative frequency curve. It's a graph that is a continuum. So it's unlike the bar chart, the bar chart that just takes one of the classes alone, histogram, depending on maybe discrete or continuous data. This continues. So it deals with the cumulative frequency. Okay? So one class is 8, the other class is 12. It's telling you, okay, from this point, you are now dealing with a total number of this item, something like that. That gives us also the spread. We always use this to also determine some of the spread of the data, because here we can always determine the quarter range, the median, and the likes. So I'm going to go through this quickly. In the cumulative frequency curve, we talk about the percentile, especially. And the ones that we have already known about the percentile are the 25th percentile, which is the first quartile. The median is the 50th percentile, and 75th percentile is the upper quartile. But it doesn't mean other percentile cannot be used. The question is, what does percentile mean? Percentile is one statistical tool that is used in admission process. Those of you that are now going into admission. Student might be ranked based on certain factors. It could be your grade, recommendation letter, whatever, and everything is ranked. Even when we write recommendation, sometimes they ask us if we rank our students and in what percentile do we think this student belongs to. If you write your SAT or some other exam, you might have come across some of this terminology. Oh, you are in so percentile. What it means is this. If a mark, let's say 50 over 60, is in the 75th percentile, what it means is that 75% of the class got below that mark. Understand? So in your cumulative frequency graph, this is 60, this is 50. This 50 was found to be in the 75. It's obvious. You can see it means 75% downward are below this mark. Understand? So if Brandy gets a point and I say, oh, Brandy's score in my class is in the 99th percentile, what I'm saying basically is that 99% of the students are below Brandy's grade. What I'm trying to tell you is that Brandy is in the last 1% of my class, the top 1% of my class. Does that make sense? So this is the idea of percentile. Now, while the question might ask you for calculate the 75th percentile and other percentile, some questions come in the form of this application, asking you, testing your knowledge of the meaning of that word percentile. Understand? That is why I think it's very important that we mention that. Now, quickly, a percentile is the score below a certain percentage, yes, just like what we have said. So when plotting the cumulative frequency curve, you find your cumulative frequency column of the table given. That will be your vertical axis. Your horizontal axis is the data itself. So the idea is this. This to this is 8. So the way it is plotted is that we use the top one, the upper boundary, okay? The upper class interval, okay? We start from here, you note this at 8, you note this as 3, at 11, and so on and so forth. Then you try to connect this back to this at 0. Because 0 is where this has not started. Remember, you're having 0, 1, 2, 3, up to wherever it is. Up to maybe 60. Maybe there are 60 students altogether in the class. Okay, you try to do that. I'll show you one example now quickly. Or maybe we can run this. Let me show you something before we run it. So this is the table, cumulative frequency first. Once you do that, then you use that to plot the graph. So you can see that 146 is more or less at 0. Because it's not the upper class interval of that particular class. 148 is the upper. So you always plot against the upper. Understand? So that the last one that attains this total sum, which is 69, will be at 176. Okay? Then, just for to complete the curves, kind of, even though this is the first one, all you have to do is just link this to 0. Because of course, what is the cumulative frequency of the class that should have had the 146? Nothing. Am I making sense? If you look at this table, suppose there's a class before here, and the cumulative frequency here is 8. Then the cumulative frequency of that class will have been 0. And that is the class that will have had 146. Am I making sense? So we just use that to complete the curve up to the starting point of the y-axis. Does that make sense? Now, once that is plotted, of course, it doesn't have to be a smooth curve. You just do an approximation, all right? But try as much as possible to make it neat. In my syllabus, in my national curriculum, we are always encouraged to get the French curve. I think I told you guys to get it during your ITCSE days about 2 years ago. Yeah, we are always encouraged to bring that, or the broom, into the exam, just to get as perfect curve as possible. It's always stressful, trust me. But you're lucky. So that doesn't have to be a smooth curve, all right? Sometimes the curve will be given, then you interpret. Sometimes you are asked to plot the curve yourself. There's no big deal to it. And the next set of things will just be questions. Find the median. So to find the median, just do 1/2 times everything. This time around, we don't need n plus 1. We're starting from 0. Okay? So you're not starting from 1, you're starting from 0. Remember. Okay? So if your median is simply 0 to the end, isn't it? And that's just 100. If this is 100, I don't know what the maximum is. 70. That's just 70 plus 0 divided by 2, isn't it? So because it's always start from 0, you don't do n plus 1. You just do that total divided by 2, or 50% of. Similarly, 75% of will be 75% times that. Okay, so you don't do n plus 1 in this case. So once you calculate what that is, you trace it back to interpret it. We'll take an example now together. Let's play this. Come on. Did you notice my volume is not increasing? Okay, I guess it's the last one.
A percentile is the score below which a certain percentage of the data lies. The quartiles we have calculated are special examples of percentiles. The lower quartile is the 25th percentile. The median is the 50th percentile. And the upper quartile is the 75th percentile. We can estimate percentiles using a cumulative frequency graph. To achieve this, we first add a cumulative frequency column to the frequency table. This cumulative frequency gives a running total of the number of data values less than or equal to the one we are considering. In this case, the data are the times of runners finishing the 2008 Olympics Women's Marathon. So, the cumulative frequency tells us how many runners finished faster than a particular time. The cumulative frequency for the first interval is 8. 8 runners finished faster than the upper bound of this interval.
Does that make sense?
The cumulative frequency for the second interval is 8 plus 3, which is 11. 11 runners finished faster than the upper bound of this interval. We continue this process, adding the frequency of each successive interval to the previous cumulative frequency. We can now represent this data on a cumulative frequency graph. The vertical axis is labeled cumulative frequency, and the horizontal axis is labeled with the variable time in minutes. The cumulative frequency graph represents this data by plotting cumulative frequencies and joining the points with a smooth curve. In Part C, we estimate percentiles using the graph. Our first task is to estimate the median. which is the 50th percentile. 50% of the total number of competitors is 34.5. We start with a cumulative frequency of 34.5, then find the corresponding time. The median is about 154.5 minutes.
Understand?
We next want to find the number of competitors who finished faster than 155 minutes. We start with the time 155 minutes on the horizontal axis, then find the corresponding cumulative frequency. About 37 competitors finished in less than 155 minutes. We next estimate the percentage of competitors who finished above 159 minutes. We again start with the time on the horizontal axis.
Sorry, just a sec.
In part C, then find the corresponding time. The median is about 154.5 minutes. We next want to find the number of competitors who finished faster than 155 minutes. We start with the time 155 minutes on the horizontal axis, then find the corresponding cumulative frequency.
Okay, fine.
About 37 competitors finished in less than 155
I hope we can follow even if
minutes.
it doesn't align.
We next estimate the percentage of competitors who finished above 159 minutes. We again start with the time on the horizontal axis, then find the corresponding cumulative frequency. The number of competitors who finished above the time is the total number of competitors minus the cumulative frequency.
I will explain that.
This is 17. To write this number of competitors as a percentage of the total, we divide by the total number of competitors.
So, stop please. So, look at this. The question that is being done to avoid confusion, percentage of competitors who took more than 159. Remember, your cumulative frequency curve showed you those that are less. So if you go to 159 minutes on the graph, which is here, what it's saying is that 52 people are less. So if the question is about more, you have to do what? 70 minus that 52. So you need to be careful when to read the exact number and when to subtract from the total. That was why we started with the meaning of percentile. It's always how many below, how many below, because everything is with respect to the beginning. Am I making sense? So you need to be very careful. And of course, to find the percentage, after you get the number, of course, the rest is easy. Okay? Any questions? All right. Then let's just listen to the audio, even if...
Then multiplied by 100%. So, about 24.6% of competitors took more than 159 minutes. Finally, we need to find the time taken by a competitor who finished in the top 20%, or in other words, better than the 20th percentile. 20% of the total number of competitors is 13.8. We start with this cumulative frequency on the vertical axis, then find the corresponding time. 20% of competitors took less than 151 minutes.
Let me try to show you the 20% graph.
51 minutes.
Okay, so if you check those that finish in the top 20%, if you check the 20% of the total, you get what? 69. So you go, click on that 69. It's not even indicated, is it?
20% of 69.
Oh yeah, it's 20% of 69.
Yeah, it's 13.8.
Wait, what was the question again? The time taken by computer who finish in the top 20%. Aha. So the top 20%, 69 is that. Start cumulative frequency from 14. You can actually do, if you do 20% of 70 itself. because it's an estimate, because everybody is 70, isn't it? So if everybody is 70, you're looking at somebody who finished in top 20%. So you can do your 20% of the 70, I don't know why they have to do 69. Just do 20% of your 70, estimate what that is. So from that estimation, you can always know the time it took, okay, for that particular person. So the top 20% of the computer took less than 151 in this case. Quickly, because of our time, so this is another method of easily identifying, but it's not necessary. In case you come across this in your book, it's not necessary. It only encourages you to write your percentile in this way. So apart from the normal stuff, you just put this label here. It's easy for you to trace. Remember, this is nowhere, 0%, 25%, and so on. So you can easily trace it, but it's not necessary. You can always work out that number and draw your line yourself. Please always indicate that line, so that even if you miss something out, the fact that the intention has been seen could give you 1 or 2 points. Okay, always indicate that line in a straight line, please. So if you look at your cumulative frequency worksheet, there are a lot of things to be done, but we cannot do that now, so we quickly go into variance and standard deviation. Please pay attention. Because of our time, I'm sorry I had to rush this. Now, who can remind me the reason why we think mean might be better than other? There is one thing that made mean stand out among the other measures of central tendency. It includes all the data. So if you are trying to get the center of a data, mean is the most appropriate because it includes everything, isn't it? But of course, mean has its own disadvantage as well. We have seen other properties that makes them maybe better than the mean. And also in some situations, mean is probably not the appropriate something. We have seen different examples. Now, in the case of the spread, if you look at your median, your mode, your range, it doesn't include all the data. Your interquartile range as well doesn't include all the data, isn't it? Now, interquartile range, because of course you have to consider the everything to know which one. But when calculating interquartile range, you only need 2. The one data that is the lower quartile, one data that is the upper quartile, then you subtract them. Okay? So there are some shortcomings to measuring the spread of a data because you are not involving everything in the data. In order to bridge that gap, to include everything to have a better picture, especially in certain situations, the standard deviation and variance are being used. They are both related. Okay? So if you check in your formula booklet or something, you see sigma squared. This is variance. Standard deviation is the square root of variance. That is just sigma. So the formulas are the same, except that one has square root and one does not. Okay? Now, let's start with variance. You want to see how it varies from the center. How something deviates from the center. Now, the center of the data, which is the mean in this regard, okay? Okay, let's look at this. Everybody's, let's say the average age in this class, including myself, is maybe 25, for example. Let's say this is the average age of the class. I want to believe my age will be what? My age will be called what in this regard? Okay, you see, so you're telling me I'm the outcast here. That's fine. Because my age will be the outlier in this regard, it will have an effect on the center, on the mean. Is that not? So let's say the mean is 25 because of course nobody is even 20 yet, I think. Unless we have a grandma hiding here. Okay. Now let's see how we all deviate from it. If we have a student who is just clocked 16, this student deviated from the mean by say 9, less than 9, isn't it? Not up to, that's what it means. We have somebody who clocked 18 tomorrow, deviating by 7. Oh, we have someone who is 36, the outlier apparently, deviating by 11. Am I making sense? Oh, maybe Krista is even a grandpa, we don't know, a grandma. Maybe Krista is 50, deviating by 25. Well, I'm not going to tell you which Krista I'm talking about. You can sort that out among the two of you. Anyway, so we can look at how, because the spread tells you the deviation as well. This is the spread we are talking about. how do these data deviate from the mean? Now, some will be positive, some will be negative. How about we just square it? 81, 49, 121, 625. If we find the average of the square of this deviation, what you have done is find the variance. Okay? Now, it doesn't make sense to square, because if we say, oh, the age of this class is going to be in years, you've squared it. Basically, this is like years squared. Am I making sense? Years raised to power 2, because the unit now is a square. Are you with me? In order to correct it back to the exact unit without any square, okay, we have to then introduce square root into our calculation, just to drop the square in the unit. And that is a standard deviation. Okay. So both of them simply are just talking about measuring the deviation of this data from the center, which is our mean in this case. Am I making sense? If you can know how everybody deviates, then you can picture it in your mind as well. That tells you the spread of the data, because you are measuring that with respect to the center. So your mean tells you more. Your mean is used to find the variance and standard deviation. Understand? And the reason for using these tools is that they consider every data involved. Okay? Now, the easiest way to find the variance and standard deviation is to create a table. Your table will consist of the following columns. Brandy, can you help me with that? Your table will consist, the easiest way to do it, if you read your, what's it called? If you read your, maybe mark scheme and it's not indicated, don't panic. This is what I will encourage you to do. If you have a district data, X will be given as single numbers, yes? And of course, if you have a group data as well, the X will be the midpoint. So it doesn't matter which data you have. You have your frequency, you get your fx, and you find your arithmetic mean, x bar. Once you find your arithmetic mean, the next column you should create in your table is the deviation. So your deviation is x minus x bar, then square it. I'm not sure I left enough table, enough column, but when I was learning, this is what I would do. I first of all find the deviation from the mean. X minus x bar. Sample mean or the exact mean, it doesn't matter. So you can, I think in your formula booklet, it's use mean, not x bar. So you can, let's follow that trend instead of that. So you can find the deviation first. The next column, you could do the square of this deviation, which means the square of this one. Remember, each deviation appears certain number of times. Then you have to do f times that deviation. Sorry. Am I making sense? And this is what you are looking at here. This is for a frequency distribution table. If your frequency is 1 for each data, then your frequency does not appear at all. Am I making sense? If you have just raw data like, 3, 2, 1, 7, 0, something like that, find their mean. Find the mean. X bar. It doesn't matter if you use any of, one is sample mean, one is population mean. But for your IB exam, you have to just consider the population mean. So, because if you read your textbook, there will be two formulas. One, we have n minus 1, so don't worry about it. Even the author of the book already told you not to worry about the sample mean. And the syllabus does not specify sample mean and sample variance or whatever. So this is what you're asked to calculate. So don't get confused with the content of your textbook. Okay? Now, if you find the mean, look at this for example. My mean is 3 plus 2 plus 1 plus 7. This is what? 5, 12. How many? Are they 6? 5. Okay, how about I remove this 0? 4 divided by 4. What is that? Is that 3? Talk to me, please. 12 over 4, which is equal to 3. So once I find this mean, the next thing I will do is this. My data.
13.
Is it 13?
Make the 7 to a 6.
Okay, let's change that to 6.
Yes, yeah, 26.
Will this be okay?
Yes.
Yeah.
Okay, once I do this, then the next thing I'll do is to find the deviation of each data from the mean. The first data is 3. You see, this does not read the rearrangement. You may not. You don't have to. 3 deviates from 3, 0. 2 deviates from 3 by what? X minus that. Then 1 minus 1. 6.
Plus 2.
Does it make sense?
Or 1 minus 2.
Minus 2. Oh, yeah, sorry. Does this make sense? I'm trying to rush because of the time. So the next thing I will do is to square this deviation, 0, 1, 4, and 9. I'll find the summation of this. This will be 14. Does that make sense? So in this case, my variance will be the addition of the square of the deviation divided by the number of data.
Square root?
Variance. Sorry, not standard deviation. Variance. So we get what? 14 divided by 4. 7 divided by 2, which is 3.5. My standard deviation, however, will be the square root of variance. So normally, no question should ask you for both standard deviation and variance. Okay? So that will be the square root of 3.5 that has been got. This square root changes the unit square that you have here back to the exact unit of the data. Understand? And once you get that, this will be 1 point something. Then this is a measure of the spread. Understand? Now, so you can find more stuff here. Now, this is what I'm saying. You see, sample variance and sample standard deviation, please ignore this part. Because here, this is talking about sample mean. X bar is the sample mean. Okay, mu is the population mean. So in the case of your IB exam, you should only focus on the population. Yeah, look, the note has been put here for you. In your HL course, you're expected to calculate based on population, not sample. That is why even the IB formula booklet focus on the population calculation, not sample. So ignore that part. And the reason why the author put that, according to the author, is that if you check the back of your book, just practicing and checking if you are right, you might be seeing 2 answers. Don't panic. One is for the population, one is for the sample. Just check that your results are there when checking. Population is like the old student. Sample is considering this class. Okay, so if we are talking about the mean age of students in the school, we consider the kindy. And up to you guys, you are the most seniors in the school. But if you're just talking about the population sample mean, maybe we take, depending on the sampling technique, we can take 2 from here, take 2 from each grade level, okay, just to make sure that every subgroup is considered. And then we find the mean. That mean is the sample mean. But the population mean is when you check everybody's date of birth on the computer and you compute the average. Okay, so 2 different measures. Understand? So please, for the calculation function, oh my God, it's already time. Can you just try this in the class, please, quickly? I'll send it to the group. Try this in the class. It's exactly what you have done before. So just make sure you are now familiar with the symbol of standard deviation and variance. It's the same function that you use initially. So you see your mean will be shown, summation of all the data will be shown, sigma x squared will be shown, sigma x squared will be used later. I will tell you in the next topic, which is the regression and correlation analysis. Then you can see sigma. You see sigma varies. One is capital letter and one is small letter.
So just check this and make sure I'm actually typing in what I'm saying. Okay.
The capital letter sigma is your summation, small letter sigma is your standard deviation. Have you done it? Aha. Did you get the 14 point something? Exactly.
And then with the normal. Which one? Standard deviation.
What?
Oh, 4.6.
X square root.
So that's
I said type
14.6.
for standard deviation.
That's the sample standard deviation.
Then that means the sigma should probably be
Okay.
variance.
Any questions?
I don't know when it's variance, but it goes to normal.
So let's go now. I'll send this to you. Any calculation you do, please check in your calculator to get familiar with it.
So you tell me.
We'll find out when it is.
Any calculation you do.
That's correct.
I mean, it's
Now remember, this is sample, isn't it? Not the population form.